Okay, so each time we do a lab in science, okay, you're going to get a template file from me that's going to look something like this. Okay, so it'll basically be the skeleton of a lab report, okay, with you having to fill in all the tissue, okay, so all the muscles and stuff you have to put in, right? But I put the bones in, so I'll have the format laid out for you, so you won't forget any parts. Okay, so you'll have your problem, okay, then you'll have your design where you identify and explain all of your variables, your manipulated variable, responding variable, and control variables, okay. Then you'll write your hypothesis, and we'll talk about the format that's expected for that here in a minute. You'll have materials, but on most of the lab reports you do, I'll have filled those in already. Okay, if it's one that you design, then you'll fill it in yourself, but that's only going to be like one lab. Okay, then the procedure, I'll already have that in there as well because it's something I put together for you. You won't have to write it out, so it'll already be there. Okay, then there'll be a section where you'll insert your data, okay, either charts or pictures or diagrams or whatever is appropriate for the lab we're doing that day. Okay, that'll go in that part. Then there'll be analysis. Okay, sometimes that'll be a few questions for you to do, or it'll require you to write like a short paragraph about something, okay, analyzing your data from the lab. Okay, then after that will be your conclusion, okay, and in your conclusion you'll copy and paste your hypothesis, okay, from the top, and then you'll explain to me why your data accepts that or supports that hypothesis, or why it refutes the hypothesis. And that's going to be, you know, again, 2, maybe 3 sentences worth of explanation, okay, as to, okay, here's what I said was going to happen, the data said that this is what happened, here's how those two things relate. They support each other or they don't, okay, and some, maybe some reasons why. Okay, that would be what would go in your conclusion. Okay, and then in your evaluation, you have to identify 2 sources of error that happened in the lab and how to fix them. Okay, most of the time they're pretty obvious sources of error, and they're pretty easy to just say, well, I would just do this instead. Like, I was only given this much stuff, so if I got more, it would be easier. Okay, little sources of error like that can be easy to identify. Okay, and then you'll be marked, okay, on your lab report, 5 marks for the design, so the variables, 5 marks for the hypothesis, 3 marks for your data, okay, 5 marks for your analysis, 4 marks for your conclusion, 3 marks for your evaluation, and then an overall, that's kind of where I'm looking at things like how well organized was it full of spelling mistakes, you know, basically did you say everything wrong, you know, yeah, could my dog have thrown up on a piece of paper and it would have got a better, obviously that's not true. Okay, but that kind of stuff, okay, that's kind of where the overall portion of the mark fits in, okay, and then it'll be a total out of 30, okay, so that's kind of what your lab report file will look like that you will get from me. Okay, so now we're going to talk about what's going to be expected in each part. Okay, so this you might want to write down. Okay, so the problem, okay, is going to be stated as a question in your own words. I will have already gone over the problem in class with you and told you what we're investigating with this lab. Okay, and so you would have to restate it in your own words. Okay, in the form of a question, just like Jeopardy. Okay. So if we're doing a lab where we're testing the effect of sunlight on the growth of a plant, okay, our problem would be very simple. What is the effect of sunlight on plant growth? Right? That would be your problem stated in the form of a question. Okay, so our example there could be, what is the effect of light on plant growth? Okay. If I'm running a lab where I'm testing the effect of light on the growth of a plant, what's my manipulated variable in that experiment? What am I testing? I'm testing one thing and then I'm measuring its effect. Okay? So the thing I'm testing is manipulated. The thing I'm measuring to see its effect is responding. Sunlight. Sunlight. Okay, so the amount of light, and actually it doesn't even say sunlight here, just the amount of light, okay, is the manipulated variable, right? Because as the experimenter, I'm going to put in several situations where light is going to be different, okay? Probably in a simple experiment, it would be as simple as this plant is going to get no sunlight. This one will get 2 hours of sunlight per day. This one will get 4 hours, and so on and so on. And then I'd be able to measure the growth of those plants based on how much light they receive. Okay, so in the design, we identify the manipulated variable, the responding variable, or sometimes variables, sometimes there's more than one responding variable, okay, and 3 controlled variables, and we explain them all. Okay? It's the explanation part that people usually forget. Okay? We're pretty good at identifying what the variables are, but then forget things like explaining. How many manipulated variables are there in any experiment?
At least one.
Only one, actually. Okay, at least one? Yes. Only one? Yes. Okay, you can only have one manipulated variable. If you test more than one thing in the same experiment, you'll never know which one of them caused the change you were looking for. Okay, which essentially makes the experiment useless, because all you've proven is one of these 2 things affected the growth of a plant. You should have run 2 separate experiments and then figured out which one. Maybe they both did, and you would find that out if you ran 2 separate experiments. Okay? So you can only ever test one thing in an experiment at a time. Okay? All right. So what we're looking at here, okay, so this is what a manipulated variable kind of thing would look like. Okay? It's the part of the experiment that is changed on purpose by the experimenter. That is what's being tested. That's our manipulated variable. Okay? For this particular experiment, the effect of light on plant growth, okay, the manipulated variable would be the amount of light given to plants, because all subjects will receive different amounts of light and light powers photosynthesis. Okay? So in my explanation, I identify it. The manipulated variable is light, and here's why. Okay? It's manipulated because everybody's getting a different amount of it, and it affects something they do. Okay, in this experiment testing the effect of light on plant growth, what's the responding variable?
Plant.
The plant? Okay, specifically what about it?
Its height, maybe.
Okay.
How much it is.
Yeah, it could be its height, could be just basically plant growth. And then I would probably, in my explanation, talk about how exactly I'm going to measure something as abstract as the growth of a plant. Okay? Really depends on the type of plant. Okay? If I'm testing, like beans, they grow pretty tall, pretty fast. Measuring their height might not be a bad idea. Okay? I could also take pictures of them, okay, and compare the pictures in more of a qualitative way. Okay? Or I could count and record the number of leaves that they grow over the course of a month or something like that. All of those could be ways to measure the responding variable. Okay? So I can be general when I say the responding variable is the growth of the plant, and then in my explanation, I should say something like it's affected by light, and this is how it's going to be measured. It's going to be measured by, the height of the plant, or the plant will be weighed every day, or the plant will be this or whatever. However way I'm going to measure that is what I would write as part of my explanation. Okay, so it'll look like this. So the responding variable is whatever changes in the experiment as a result of your manipulation. Okay, so the growth of the plant is going to be affected by how much light the plant gets. Okay, in an experiment where I'm testing the effect of light on plant growth, what kind of things am I going to want to control? Okay, so just as a quick review, controlled variables are the things that you make sure stay exactly the same for the entire experiment for every subject, because they could also affect the growth of a plant if they're changed, okay, in this case. All right, so what are some things I would want to control?
The amount of water each plant gets.
Exactly. Every plant needs to get the same amount of water. If they don't, we know water affects the growth of a plant. The plants that get more water are going to grow better. So every plant has to get exactly the same amount so that that is affecting them all equally. Okay? What else?
The temperature.
Temperature. Yeah. I got to make sure they're, maybe all in the same room, but each of them gets their own lamp or something like that. Okay? Where I can control the amount of light. Okay? But I can make sure that because they're all in the same room, they're all at 20 degrees Celsius. Temperature can affect how fast they grow. What else?
Soil.
Soil. I got to grow them all in the same dirt. So I get a bunch of pots that are the same, okay? So that I can put exactly the same amount of dirt, same kind of dirt in every plant, because dirt can affect how a plant grows, okay? You followed what we did there? I identified them all, and I explained how I would control them and what effect each one would have. Okay, so I said I'm making sure it's the same kind of dirt, same amount of dirt, because dirt can affect how a plant grows. Okay, amount of water. Water is important for plants to grow, and making sure they all get the same amount each time. Everybody follow there? Now, in an experiment like this, there could be a dozen control variables. I'm only asking you to identify 3. Okay, so kind of pick the big 3 that you think are really important, identify them, explain how they're being controlled and why. Okay, so that's your control variables. So this one's going to be a little bit longer because I've got an explanation for each one there. Okay, basically, controlled variables are anything that could affect the experiment were they not controlled. Okay, and so we want to make sure we explain how that works. So once we have the variables done, okay, then the next thing we need to do is come up with our hypothesis. Okay, now there's a lot of kind of differing opinions on how a hypothesis would work. Okay, especially when you're coming from like junior high to high school. Okay, generally, okay, a hypothesis needs to be a hypothetical statement. Okay, it's not a question. That's what the problem is. The problem is the question that we're investigating. The hypothesis is a statement. Okay, when you write a proper hypothesis, you are setting yourself up to be either right or wrong. Okay, and it's okay if a hypothesis ends up being wrong. In the real world, most hypotheses are. That's how science works. Okay? You usually have to get something wrong a bunch of times before you finally figure it out. Okay? So in a hypothesis, we say a couple of things. The first thing we say in a hypothesis is, this is what we think the problem is about, or what is causing this phenomenon that we're studying. Okay? Then we talk about briefly how it's going to be tested. Okay, so like not a detailed procedure, but a brief statement about how we're going to test it. And the last part is predicted results. So basically it's, if this is true and I do this, then this is going to happen. Okay, that's how a hypothesis goes. Okay, and you set yourself up as being right or wrong. Okay, at the end of your experiment, it's going to be one or the other. Either what you said was going to happen happens, or it doesn't. Okay, and then that's what you explain in your conclusion. Okay, this is what happened. Here's how it compares to what I predicted would happen. That's why I was, my hypothesis is acceptable or not. Okay, so a hypothesis always contains these 3 words: if, and, then. If this is true and this experiment is run, then this will happen, or then this will be accomplished, or something along those lines. Okay, so what we're looking at is an if, and then statement. Okay, so it communicates what the relationship between the manipulated and responding variable is thought to be. Okay, so for the one we're doing right now, we would talk about what we think the effect of light on plant growth is. Okay, so for this experiment, okay, what we're doing, okay, is we're testing the effect of light on plant growth. So the if part needs to say, this is what the relationship between light and plant growth is. So our example here says, if plants require light for growth. Okay, there's the relationship. Plants need this stuff. They won't grow without it. Okay, that's the if part. Okay. The and part talks about the experiment. And 5 identical plants are given different amounts of light. That's a very general description of my experiment. I'm not doing every little thing in my hypothesis. That's for my procedure. In my procedure, I'll say, get a bunch of 2-liter pots, fill them full with, the Home Depot potting soil, and then put the plants in, whatever. That's all the instructions I would put in the procedure. I just need to say, in general, this is what I'm doing here. Okay, and the then part is, what are my predicted results? Okay, well then, the plants that receive the most light will show the most growth. I'm going to be right or wrong on that now. Okay, now if I do this and I have one plant that's in total darkness, that plant's going to what? It's going to die. If I give one plant 24 hours of sun per day, what's going to happen to it? it's going to die. Okay? There's kind of a tipping point for the amount of light a plant gets. Okay? Plants naturally need to have periods of darkness. That's where they evolved, in a place where they have light and dark. Okay? There are some of the chemical reactions that are required for photosynthesis that actually need to take place in the dark. We actually call them the dark reactions. Okay? There's two halves. Okay? So if I give a plant 24 hours of sun a day, it's also not going to like them. Right? So I'm going to be wrong. Okay? But I'll be able to say that my hypothesis in this form is not correct. However, there is a kind of there is a trend towards increasing plant growth, and then it falls off. There's obviously too much of a good thing after a certain point. Okay? That's the kind of thing I would explain in my conclusion. All right? Everybody understand how that hypothesis is going to go? This is the part people struggle with the most, especially on the first few labs, is getting their hypothesis right. Okay? The if part is what you think is going on. Okay? The and part is the experiment. The then part is your results, or what you're going to be able to do afterwards. Okay? All right. So what we've got here, if, okay, the cause of the problem, and briefly describe the experiment, then what you expect if you are correct. Okay. Also, we generally try to avoid the use of I, us, and we in a hypothesis. Okay. We want to make this as scientific as possible and as repeatable as possible. If you put in your hypothesis, I'm going to do this, when somebody wants to replicate your experiment, you have to be there. Okay. So we want to try and avoid the use of I, us, and we in there. Now, for your procedure, okay, most of the time that's going to be something I give you, but there is a lab where you design the experiment yourself. So it's a detailed step-by-step set of explicit instructions. That doesn't mean it's full of four-letter words, by the way. It means that it's just really, really clear. Okay, there's no misunderstanding. Okay, when you write a procedure, you need to write it so that like a 4-year-old could follow it. Okay, do this, then do this. It's got to be like a cookbook. Okay, exactly this much, and put it in here exactly now. Okay, all of that kind of stuff. So it's exact, okay, explicit directions for preparing and performing the experiment. Okay, and then you're going to have your observations. That's your data. Okay, so that's charts or graphs or any other data, including anecdotal notes. Okay, anecdotal notes are things that you might just write down. Like, notice that there was some discoloration on some of the leaves on plant number 5 around day 4. Okay, that would be an anecdotal note. It's not really, a measured thing, but you wrote it down. Okay, it's especially important in more of the humanity sciences, like psychology and stuff like that, where you're not really measuring things. Everything's much more qualitative. Patient A experienced, manic episodes where they were nearly uncontrollable, while patient C fell asleep all the time. Those would be anecdotal notes. Okay. For your analysis, okay, in your analysis, that's going to be where maybe some calculations are done, if it's a type of lab where you've done mathematical measurements, okay, where you're going to review and compare your data. Okay, so looking at what happened when I mixed these two things, it exploded. Okay, when I mixed these two things, absolutely nothing happened. Okay, why would that be? You're analyzing those. Okay, so for most of the time, that's going to be answering questions and performing the calculations I ask you to do. Okay, and then detailed explanatory answers are required. Yes and no are not detailed explanatory answers. Make sure you have sentences, complete sentences there, talking about what's going on. Okay, and then we have our conclusion. Okay, so restate your hypothesis. Just copy and paste it. Okay, you're doing this in Google Sheets or in Google Docs anyway, so just copy and paste it. Then, using your data and your analysis, explain why your hypothesis is accepted or rejected. So for our plants with the light experiment, okay, we can say, as it was found that plants receiving small amounts of light and very large amounts of light showed little growth, it can be concluded that plants require certain amounts of light and darkness to be healthy. Therefore, the hypothesis is rejected. Because my hypothesis says more is better. Okay? So the plant that got the most should have shown the most growth, and that didn't happen. Okay? Now, I've put in my conclusion what my analysis says, okay? But it does say that my hypothesis was wrong. Okay? And that's all right. Okay? You learn more in science from being wrong than you do from being right. Okay. So does that sort of make sense there? Okay, so it's a reasonably long explanation for why I'm saying what I'm saying. You never want to write, I was wrong, or I was right. Okay, la-di-da. Okay, you have to say more than that. Okay, why were you right? And nobody's ever right or wrong. Okay, you have to kind of say, this is what happened and it goes with my hypothesis or it doesn't. Okay, and then lastly, you want to have two sources of error and suggest improvements. Okay, so in a lab like this, maybe we noticed that our light source put out some heat. Okay, and that could have affected the temperature for the plant while the light was on, possibly interfering with the results. Okay, what would we do in the future? Use a light source that doesn't emit as much heat, maybe like an LED bulb instead. Okay, another source of error could be, maybe there was some seeds that didn't germinate that were planted. Okay, that could certainly be a source of error. So maybe the source of the seeds was not very good. Try this experiment again with a different seed supplier or different type of plant altogether, okay, or something like that. All right, so you've identified what could have caused some errors and some ways to fix it. All right, does that make sense to everybody? Okay, cool.